Okay, hello. Today we are talking about the chili pepper productive chain. We are Nicolas Rivera and Juan Bonilla. In this case, we are talking about technological solutions. One of these is a irrigation system, a sorting by weight, a chili pepper selector, a traceability, a tagging, and a virtual reality production plan. Starting with the raw material winning, we are talking about the chili pepper productive chain. This start in production in Colombia, is transformed in Colombia and in United States, and distribution in United States. Some issues in raw material winning could be an inaccurate measurement and a contamination and cross-contamination, variability in moisture content, time-consuming yet and simple task, and assorted mistakes. We have four objectives. In this case, in haze and quality assurance, increase efficiency, reduce waste, and ensure food safety compliance.
All right, so talking about the process before automation, basically an employee takes a sack of chili pepper, he weighs it, and some time-consuming intermediate sub-processes take place before that provider can be paid according to the weight he provided in chili pepper, and also before an estimation of the chili pepper paste can be done. Basically, the proposed system consists in a scale that's connected to the internet that can actually transfer time information in real time, um, and this can shorten processes length. So basically, the chili pepper is weighted, and then it is classified into either above average, average, and below average, and some other metrics can be uh, calculated at the same time, as we will see. All right, so for this small scale simulation, we can expect the input to be between 1 and 1,000 grams, and it is the measure of chili pepper weight. And the outputs of this system is the paste estimation, which can range between 100 and 1,000 milliliters, and the cost estimation, assuming we're paying each gram for 6,500 pesos, and it is measured in COP. So the implemented system has some hardware parts and some software parts. Talking about hardware, we have the ESP32 card, which is the Arduino, the HX711 amplifier, and the load cell, which is the scale. And talking about the software, we're gonna use the UBDOT's cloud service and the Arduino coding. So talking about the assembly design here, the chili pepper sack is placed in the load cell platform. It's gonna translate its analog signal into an electro one, which is gonna then be amplified by the HX711, and it's gonna then transfer that information to the Arduino controller, which is connected to the internet, and it's gonna send that electric signal to the cloud service UBDOTS, uh, where it can be remotely visualized and translated into variables that we can understand, such as paste estimation and costs. All right, so here we have the setup. That's the load cell, and that's the platform for measuring the chili pepper sack. I'm placing the chili pepper sack. Um, that's the HX711 amplifier. So that's transferring the signal and amplifying it uh, to the ESP32 controller. And in this computer over here, you can see that it's measuring at about 15 seconds, at a rate of 15 seconds. And that electric signal is then transferred to the UV dots platform. That's the electric signal for the current weight being measured, and that signal is then translated into a variable we can understand, which is in grams, and also from that we can estimate the chili pepper paste and the cost for that chili pepper sack. All right, so talking about the results, we have a screenshot of the UV dots display. So the electric signal is the one at the bottom. Then it is translated into the second from bottom to top, which is the weight. Um, and for 73 grams, or let's say 73 kilograms for practical purposes, we're expecting to pay around 474,000 pesos. And we can expect 116 milliliters of chili pepper paste.
In this case, we can see four advantages. The first of all is improved liquidity, that is the producer and supplier receive quicker payments and enhances their cash flow and enable them reinvent in production and cover operational costs. The second advantage is increased efficiency. That's speeding up transaction, reduce waiting times, and optimize the supply chain. The third advantage is better business relationships. Quick transaction and build trust and collaboration between buyers and suppliers. And the fourth advantage is competitive advantage, that companies that operate more quickly can better afford and respond to market demands and size emerging opportunities more efficiency.
In conclusion, simple yet time-consuming processes like weighing can be optimized with the implementation of automation concepts to reduce process time and give a competitive advantage to companies. We can also say that the process of system design and validation is more challenging than it appears, often presenting numerous issues in achieving successful signal transmission and operational integration of software and hardware.